Hi guys, good night everybody. Just let me know if you guys can hear me before I start, please. All right, great. All right, all right, guys. So I have a little time this afternoon here, so I decided I'll go live. Right. I know sometimes the night before the exam we get a lot of students coming onto the live, right? So I may not be able to monitor the chat. All right. So um, just for your knowledge, right? I mean, we know the maths exam is tomorrow, right? And we know that the exam is going to be 10 questions, right? We know that question one, right, is going to be based on numeracy, right, or numerical topics, right? And this could include things like decimals, fractions, right? And we also get consumer arithmetic in that first question, right? So the first question, like I said here, it is based on numeracy, right? It's also based on consumer arithmetic. And when I say consumer arithmetic, it can be things like profit, right? Yeah, it can be based on things like profit, loss, right? Percentage loss, percentage gain. It can be things like simple interest, right? We can also get questions on appreciation, depreciation, right? Compound interest, right? So typically question one, the second part of question one is typically based on real life scenarios, right? We can also get currency conversion inside here, right? And that's typically what we get in question one, right? Now, question two is a challenge for most students, right? So if you think you're having trouble with question two is algebra. Generally, the rest of the Caribbean is also having issues with this as well, right? So question two is solely going to be based on algebra, and it's usually a 9-mark question, right? And it could be based on several different things. It could be based on factorizing, right? Substituting variables into an equation. It could be solving simple equations, solving things like simple inequalities, right? We can get simultaneous equations inside of this. So those are the kinds of questions that we get in question two. It's going to be based on algebra, right? Your third question in your exam is going to be based on geometry, right? And that's geometry as well as basic trigonometry, not sine rule and cosine rule, but basic trigonometry. Things like Pythagoras' theorem, right? Or the sine ratio, cosine ratio, or tangent ratio. That could also appear in your third question. In your third question, we also get transformations inside here, right? So transformations typically appears here. There are 4 transformations that you all need to know for the exam. That is a translation, a reflection, right? A rotation, right? And also an enlargement, right? Those are the things that we typically get in the third question, right? In question 4, right? In question 4, what we typically get is a question based on functions. So in question 4, now question 4 and question 8 are based on the same section of the syllabus. So we can get things like straight lines, right? Equation of a straight line, parallel lines, perpendicular lines, all of that could appear here, right? We can also get simple functions inside this as well, right? Now every year we do get a question on functions, so I don't expect tomorrow to be any different, right? Question 8 is related to question 4, right? And we can get questions like quadratic graph, right? So we can get quadratics inside here. We can get linear programming, right? You can also get simultaneous equation with one linear and one non-linear in question 8 as well, right? So it depends on what they decide to bring tomorrow. Question 5 is usually our statistics question, right? Now, with respect to statistics, we have several things you need to know for the exam. You need to know things like line graphs. We need to know bar graphs. We need to know histograms, cumulative frequency curves. They love to bring that in the exam, right? Also pie chart as well, right, under statistics. So we need to be able to calculate things like mean, median, and mode based on data in a table, right, or raw data. Question 6, right, is usually our measurement question, right? Question 6 is measurement, right? And these include things like volume of a solid, right? A prism, a sphere, a cube, a cuboid. We also get area as well. Area of a circle, area of a square, area of a sector, area of a segment. All of that could appear in question 6. Question 7 is your pattern question, right? Now the pattern question is a question that you could get some easy marks inside it, right? We can get some easy marks in a pattern question, right? Typically they will give us some diagrams and we may have to come up or complete a table in question 7, right? Question 9. Question 9 is typically based on trigonometry and geometry as well, right? So we get things like bearings, sine rule, cosine rule. We can also get circle geometry as well. Every year we do get a question on circle geometry. You all need to know the rules for circle geometry, right? There's several of them that you need to remember, but what they do, they combine it in one question most of the times, right? And then question 10 is based on vectors and matrices, right? Question 10, vectors, matrices, right? Now, I get this a lot from students. Students say, which questions should we do first? Should we do the paper in order, right? Now, the thing is, the paper does not have to be done in order, right? The paper does not have to be done in order. You can decide to do the easy questions first, right? And my suggestion is to do that, right? Do the questions first that you are familiar with, right? Don't bother with questions that are difficult. Question 9 and question 10 are usually the most difficult questions on the paper, right? All right, so I just wanted to just make sure you know what could come in the exam, right? And we're going to start with some exam type questions here, right? So we have the points A, B, C, and D on level ground. So this is something that we could get in question 9 of the exam, right? A vertical pole of height 5 meters is at a point A. So we have a pole here at this point A here, right? We have some links. We have AD is 16.2, right? BD is 11.5. And angle ADB is 62, and angle BDC is 52, and angle DBC is 93. So we have a diagram here, and all these points are on level ground, right? The first thing we want to calculate this distance here, AB. Could anybody in the chat tell me what am I going to use to calculate that distance AB there? What you all think we're going to use there? All right, so I've seen a lot of people saying the cosine rule. Yes, I would probably use the cosine rule in order to calculate this, right? So let me get 1 second. I just want to get a copy of the diagram here. Hold on. Right, so this is our diagram here, right? All right, so the first thing we want to calculate that distance AB. This is this line here, right? So I saw a lot of people saying use the cosine rule. Yeah, so you all need to know the conditions under which you use the cosine rule. The cosine rule is used if we have a triangle and you know all the lengths and no angles, right? Or if you know two lengths, in this case 16.2 and 11.5, and you know the angle in between here, right? Now on the formula sheet, you are given the cosine rule. In the maths exam, you are given the cosine rule. So in this case here, I'm going to apply the cosine rule. Now when you're using the cosine rule, we are looking opposite, we are looking at the side opposite the known angle. So you're going to write out the cosine rule based on what is given to you guys. So we're going to have AB squared is equal to 16.2 squared. So I'm applying the cosine rule here, plus 11.5 squared, right, minus, open brackets, 2 multiplied by 16.2, right, multiplied by 11.5, multiplied by cosine of 62, right? Now, the cosine rule looks like this. If you look on the formula sheet, it may look like this. C squared is equal to A squared plus B squared minus 2AB cosine C, right? That's typically what the cosine rule looks like. Now, what I've done here, I'm applying the cosine rule, but I'm using the triangle ADB here. So AB squared, right? If you are given a question like this in the exam, try to work it out step by step. So that's 16.2 squared. So that is about 262. Now in this case here, you can actually round off, right? You can round off when you're working out these things here. So this is about 262, right? Plus 11.5 squared, right? And you're going to get about 132, right? Minus, and we work out all of that there. So that's 2 by 16.2 multiplied by 11.5, right? Multiplied by cosine 62. And you're going to get about, let's say 175, right? 175. So therefore, AB squared is equal to, so this is 262 plus 132, right? Minus 175, and you're going to get 219, right? So when you get a question like this, try to do it step by step, right? Don't rush the question. So this is going to be the square root of 219. So therefore, AB is equal to second function square root, and you're going to get about 14.8, right? And look at the unit that we have here. We're working in meters, so that's about 14.8 meters, right? So if you all get that, that should be the answer, right? So that is that's the first part, right? So that's using the cosine rule in order to work out the distance AB. Next thing we want to do, we want to work out the distance BC, right? So again, let me just put the triangle on a sheet by itself. Right? So here's what we want to work out. We want to work out the length BC, right? That's this length here. Could you all tell me in the chat, what am I going to use to work out that length? Right, I'm seeing sine rule, right? So for those of you who intend to learn, right, try to focus on what I'm saying, right? Those of you who are here just to waste time, right? Please just leave if you're wasting time, right? Those of you who are here to learn, just focus on what I'm saying, right? I don't have time to check all the chats, right? So we have a triangle here, right? And some of you all are saying we're using the sine rule. So here's when you use the sine rule. You're going to use the sine rule when you have two sides and one angle, or you have two angles and one side, right? But the key thing with the sine rule is that you need to have opposite lengths, right? The angle and the side needs to be opposite. So watch this, right? We want to work out the length. Hold on, something. You want to work out BC, right? BC. Make sure I have everything to work out BC. Right. So what I can do, right? I can actually work out what is this angle here. Right, this angle here is actually, right, this angle here is going to be 180, right, minus 93 plus 52, right, that's going to give me 180 minus, open brackets, 93 plus 52, close brackets, and you're going to get 35 degrees, right, you're going to get 35 degrees. So now, if I want to apply or use the sine rule, this is what needs to happen. I need to have, now the objective is to find BC, right? Now the side or the angle that is opposite BC is that 52 degrees here. So we have this, right? Now you also have the 11.5. That 11.5 is actually opposite this angle here. So when you're using the sine rule, so if you look at the formula sheet, you might see the sine rule looking like this. A over sine A is equal to B over sine B. Right? That's typically what the sine rule looks like. So we can write BC, that's the length that you want to find, all over sine of 52, because that's the angle opposite the BC, and that is equal to 11.5 all over sine, right, of the angle we just worked out there, which is 35, right? Because 11.5 meters is opposite the 35 degrees. So all I've done there is enter the information based on the sine rule. So you want to work out BC, we're just going to cross multiply. This by this has to be equal to this by this. In this case here, right, we're going to say that BC, right, multiplied by sine 35 is equal to 11.5 multiplied by sine 52, right? So BC is equal to 11.5 multiplied by sine 52, right, all over sine 35, right? So therefore BC is equal to, right, so that's 11.5 multiplied by sine 52 divided by sine 35, and you're going to get about 15.8, right? This is going to be about 15.8 meters, right? Right? Don't round off your answers too early, right? Don't round off your answers, so don't go and put 15 as your answer, right? In this case, we'll put 15.8 as the answer, right? So this is an example of using the sine rule here in order to work out a particular length, right? So that is part 2. And the third part, we want to work out the angle of depression at the point D, right, from the top of that pole there, right? So remember, you are placing a pole here, right? Now, whenever they tell you that you have points on level ground, think of this as you're looking at it from above. You're in a plane and you're looking down and you're seeing this shape here. You're seeing this shape ABCD, right? But there's a pole at the point A there. So if you're looking at it from above, the pole is going to appear as a dot, right? So if you want to understand the question itself, you have to look at it from a side profile, right? Now let me explain what I mean by a side profile. So this here is what we see, right? This is the top view here, right? But if I watch this thing from the side, right? Let's say this is point A here, right? We have a pole, right? You have a pole here, right? And then we have a point D, right? This is point D here. That distance AB is 16.2, right? And this is the top of the pole here, right? And the question is saying, let's go back to the question. Right, so the pole, right, that's not that. Right, so the pole, they told us the height of the pole. The height of the pole is 5 meters, right? So on your diagram, right, sorry, yeah, so the height of the pole is 5 meters here, right? Now it's a vertical pole, so this angle has to be 90 degrees. So let's draw a line from, let's put, this here is actually B. Not B, sorry, D, right? This point is D here, right? That's this point here, right? Now the question basically says, what is the angle of depression of the point D from the top of the pole, right? The angle of depression from the top of the pole. So let's draw a line from the top of the pole to the point D, right? So when they ask you for the angle of depression, right, what you are doing, it's as if you are looking at this thing at this point here, right? But you're looking downwards to the point D. That's what you're looking at. You're looking downwards to the point D. So the angle of depression that they're looking for here is this angle here. Let's call it theta. So that's your angle of depression of the point D from the top of the tower, right? Now that angle there is also this same angle here, because this horizontal line here, this here, and this horizontal line joining A and D, they are parallel. So those two angles are what we call alternate angles, right? So now we have to figure out that angle there, and we know two sides. We know this length is 5 and we know this is 16.2, right? Now again, when it comes to right angle triangles, there are three ratios that we could potentially use. That is SO, CA, TOA, right? So we have sine, cosine, and tan. Now, before you do anything, because I see students doing this all the time, they're guessing what ratio to use. This is not a guessing game, right? So what we do, we need to label our triangle in terms of opposite, adjacent, and hypotenuse. So the side that is opposite the 90 degrees is always called your hypotenuse. The side that is opposite the angle that we are working with is called the opposite, right? And then what you're left with, the 16.2 here, is your adjacent, right? Now we have to make a decision, right? So this is the procedure we use in order to solve something like this. So you know what the opposite is. The opposite is 5 meters. You also know what the adjacent is. The adjacent is 16.2. So you're looking for one of these ratios here that we have opposite and we have adjacent. Which ratio am I supposed to use? Am I supposed to use cosine? Am I supposed to use sine, tan? What am I supposed to use? Right? Seeing some people saying tan. Yeah, it's a logical thing that we have to do here, right? We're going to use tan because we're dealing with opposite and we're dealing with adjacent, right? So in a question like this, we're going to start off by writing down the ratio. So tan theta is equal to opposite over adjacent, right? So we're going to say tan of theta. We don't know what this is. The opposite side is going to be 5, right? And the adjacent is 16.2. So therefore, theta is equal to arctan, right, of 5 over 16.2. And that's going to give us my angle of depression here, right? So that's second function, tan, open brackets, 5 divided by 16.2, close brackets, and you're going to get about 17.2 degrees. Right? When you all are writing on your angles, right? Normally we put angles to one decimal place unless CSEC tells us that we're going to write our angle to the nearest degree, right? So don't put your angles to two decimal places, eh? One decimal place is fine, right? Right? So, I know like a million questions coming in the chat and there's a lot of people here coming for this live, right? So guys, it is being recorded, right? So you can go back to the recording if you need to, but it's a systematic method that I'm using in order to work this out, right? We're not guessing here, right? So that is something that could potentially come under trigonometry, right? How about next question here? I have two matrices, A and B, right? They are both 2 by 2 matrices. And the first thing I want to do, I want to calculate A minus B squared, right? You want to calculate A minus B squared. So let's start off. Right? So this is our matrix here, right? And what we are attempting to work out, we want to work out A minus B squared, right? That's the matrix. Now, if I were you and I got this question in the exam, the first thing I'll do, I'll work out what is B squared first before I do anything else. Now, B squared actually means, right, B multiplied by B, right? Now, this is a matrix that you're working out here. You don't just go and square this and square this and square this and square this, right? That's not how you work that. It is actually a matrix multiplication and it's B multiplied by B. So you're going to write down minus 1, 3, 4, 1, and you're going to multiply that by minus 1, 3, 4, 1, right? That's how you're going to multiply this. It is the multiplication of a 2 by 2 matrix, right? Now, whenever you multiply a 2 by 2 matrix, you're going to get 4 elements as your answer. So E11, E12, right? E21, and E22, right? Now, there are some students who can just work this out and put the final answer one time. And if you are okay with that, that's fine, right? But I'm just going to show you step by step how we work this out. So we need to find those 4 numbers here. So E11, E12, E21, and E22, right? Those are 4 numbers, sorry, that we need to calculate. So in this case here, whenever you're multiplying matrices, right, we always do row by column. So if you want to get E11, right, we're going to take this row and you're going to multiply it by this column here. That's what you're going to do, right? So this is going to be minus 1 multiplied by minus 1, right, plus 3 multiplied by 4, right? And if we add this up here, minus 1 by 1 will give me positive 1. And then we have to add that to 12. So we're going to get 13, right? So if some of you all in the chat here trying to work it out at the same time, just double check my answers as well. So E11, I'm getting 13, right? Then if we want to work out the next one, right, E12, you're going to take this same row, right? But now you're going to switch and you're going to multiply by this column here, right? So when you work that out, that's going to be minus 1 multiplied by 3 plus 3 by 1, right? So minus 1 by 3 will give us minus 3, and then 3 by 1 is going to give us 3, and you're going to get 0, right? So like I said, just double check my answer, see if you all getting that as well, right? Next one. You need to work out E21, right? So let's use a different color here. So now you're going to switch now, but you're going to switch to this row here. So you're going to take that row and multiply by this column. So that's going to be 4 by minus 1, right? Plus 1 by 4, right? So that's going to be 4 by minus 1 is going to give me minus 4 plus 4. And you're going to get 0, right? So like I said, just double check my answer there, right? The next part here now, we need to work out the last one, right? That's E22, right? And this here is going to be, we're going to take the same row here, but now you're going to multiply by this column here, right? So when you're doing a matrix multiplication, you have to do it in a systematic way in order to get your answer, right? So this is going to be 4 multiplied by 3, right? Plus 1 by 1, right? So that's going to be 12 plus 1. So you're going to get 13 here, right? So the final answer, when you multiply those two matrices, right, that is actually going to be 13, 0, 0, 13, right? So that's our b squared. That's not the final answer, but that's b squared, right? Now if we go back to the question here, right, what we are attempting to work out, we want to work out a minus b squared. That's what you want to work out, right? All I did was work out this piece here. So now we still have to do the subtraction, right? So let's take this, right? And you want to work out a minus b squared, right? So a is given by 2 minus 2, 1, 4, right? And you're going to subtract b squared. And we worked out b squared just now and we got 13, 0, 0, 13. 13, 0, 0, 13, right? So when you are subtracting two matrices of the same order, right, what you're going to do, you are going to subtract corresponding elements, right? That's basically what you're going to do. Subtract corresponding elements. So 2 minus 13, you're going to get minus 11. Minus 2 minus 0, you're going to get minus 2. 1 minus 0, you're going to get 1, right? And then the last one is 4 minus 13, and you're going to get minus 9, right? So whenever you're subtracting, right, matrices, they have to be of the same order, and all you're doing is subtracting corresponding elements. That's it. That's all you're doing, right? Right? So again, right, this is this part of this question here. We worked out a squared minus b. Next thing we want to work out the inverse of that matrix, right? So you all have to be able to calculate the inverse of a matrix, right? So you have a matrix A here, right? And you want to determine the inverse, which is this, right? The inverse of a matrix, the first thing we need to do is to find what we call the determinant of the matrix. And to find the determinant of this matrix here, you're going to take this number, multiply by this number. So that's going to be 2 multiplied by 4, minus, you're going to take this number here and multiply by this number here. So that's going to be minus 2 multiplied by 1. So 4 2s are 8 minus, right, minus 2. And therefore, this is going to give me 10, right? That's the determinant of this matrix. The inverse, right, which is written like this, is actually 1 over your determinant multiplied by something called the adjoint of the matrix. Now, the matrix A is given by 2 minus 2, 1, 4, right? Whenever you have to find your adjoint of that matrix, what you're going to do, you're going to swap these two positions. So the 2 and the 4, you need to swap them. So therefore, this 4 is going to come here, the 2 is going to come here. The next thing we need to do is to put a minus sign in front of this and a minus sign in front of this. So that negative 2 becomes positive 2, and this here is going to become negative 1, right? So this here is the inverse of this matrix, right? Now, what I normally tell students to do, if we were doing a simultaneous equation and we were using a matrix method, then I will tell students leave their inverse in this format here. But if CXC just asks us to write down the inverse, then what I want you to do, I want you to write it like this, right? This will be 4 over 10. This will be 2 over 10. This will be minus 1 over 10, right? This will be 2 over 10, right? So this matrix here is your inverse, and you can go ahead and reduce it if you want, right? Reduce the fractions if you need to. That's not a problem, right? So that is this first part of this question. We wanted to find a minus b squared. You wanted to find the inverse. Part B of the question here, right? We have a matrix, and this matrix M is given by 2x, 9, right, 8, and x. State the values or calculate the values, right, of x for which a matrix is singular, right? Now, a singular matrix is a matrix that has a determinant that is equal to 0, right? Now, we have two kinds of matrices. You have matrices which are singular and non-singular, right? In this case here, we have a matrix, and they are telling us that the matrix is singular. This has meaning, and what that means is that your determinant has to be equal to 0, right? So we're going to take the same matrix M, and we're going to work out what is your determinant. So the first thing we do, we take this, and you multiply by this. So the determinant is going to be 2x multiplied by x minus, and then we're going to take this number here and multiply by this. So this is going to be 9 by 8. And you're going to put that equal to 0 because you know the determinant is equal to 0. So this is going to be 2x squared, right, minus 9 8 is 72 is equal to 0. So therefore 2x squared is equal to 72. And therefore x squared is equal to 72 all over 2. So therefore x squared is equal to 36, right? Now, if I want to work out x here, that's going to be the square root of 36. Now, generally, students might just put 6 as the answer. But I want you to read the question carefully. They said find the values of x. Whenever you find the square root of a number, there are two solutions, a positive answer and a negative answer. So there are two values of x which could satisfy this equation. So x is equal to positive 6 and x is equal to negative 6, right? Right? So let's see what else I have here. So this next part of this question here, right? Make sure I'm not missing anything. Yeah, this part of this question here, right? So I have a diagram and it shows a line AB on a grid. And the first part here says to state the vector AB in the form XY, right? Before I write it down, you all know what that vector is? What is that vector there, right? right? I've seen some answers inside here. Let's see what's going on, right? In this case here, right? So you're moving from the point A to B, right? So this is your vector here, right? Now, if you're going from -1, right, to +5, right, that means check how many units you're moving to the right. You're moving 1, 2, 3, 4, 5, 6 units to the right, but you're not moving up or down, right? So this vector that we're talking about here for the vector AB is going to be 6, 0, right? It's 6 units to the right, and your movement in the y direction is going to be 0, right? Part 2 here, the vector BC is given by -3, 4, right? Plot and label the point C on the diagram, right? So we have -3, 4. Now, how are we going to figure out where this point C is, right? So all you're going to do, let's erase some stuff here. Now this vector here, right, this -3, 4 tells me that I'm moving 3 units to the left, and then I'm moving 4 units upwards, right? So let's start at the point B, because you want the vector BC. You're going to move 1, right, 2, 3 units to the left, and then you're going to move 4 units upwards. This is 1, this is 2, this is 3, and this is 4 here. So that's going to take us to this position here. So this here is the point C, right? That's the point C. So I'm just using the vector -3, 4 in order to locate exactly where the point C is, right? Now they want me to, in this case here, they want me to draw this, right? So plot and label the point C. So that's the point C, right? I'm just going to draw a line that is joining B and C, right? So this here is your vector BC, right? The third part, we want to calculate what is the magnitude of the vector AC, right? We want to get the magnitude of the vector AC, right? So in this case here, let's draw a line from A to the point C, right? So this is a vector here, right? Now that vector there, right, we can figure out what it is because you're starting at A and you want to end up at C. So therefore you're going to go 1, 2, 3 units to the right. So the vector AC, right, is equal to 3 units to the right. So that's 3. And then you're going to go 1, 2, 3, 4 units upwards. So therefore that vector there is given by 3, 4, right? So that is that vector AC. Now the question is asking us here for the determinant, sorry, not the determinant, the magnitude of the vector AC. Whenever you see a vector with 2 lines on either side, they want the magnitude of the vector or the length of the vector. So if you want to get AC, right, magnitude, all you need to do is to use Pythagoras' theorem. So that's going to be 3 squared plus 4 squared. Find the square root, right? So this here is going to be 9 plus 16 square root. So that's the square root of 25. So therefore, that magnitude is going to be 5 units, right? That's the magnitude there. It's going to be 5 units, right? And the final part, ABCD, is a parallelogram, right? Plot and label the point D on the diagram. So you wanna create a parallelogram here, right? To do that, you need to know that the line AB has to be parallel to the other line, right? So this is 1, 2, 3, 4, 5, 6. So let's just count 1, 2, 3, 4, 5, 6. So therefore, this point here is going to be where D is. And if you want to complete this parallelogram, we're just going to put a line here. And we're going to put a line here as well, right? So this is our parallelogram here, right? So this one is a vector question that is not too bad, right? Right? I have another sample question here for you guys, right? All right, let's shift gear a little bit, right? Let's look at this question. Now the table shows information about the times, T-minutes, taken by 270 students to complete an advanced maths problem, right? Draw a histogram to represent the data in the table, right? Now, I just want to ask one or two questions here before I work that out, right? Let's say for this class interval here, right? Could you all put for me in the chat, right? What is the lower class limit? That's my question to you. For that interval here, 26 to 35, I want to know what is the lower class limit. What do you all think that is? Right, I've seen some answers in the chat here, right? I think they're looking correct, right? The lower class limit here is going to be 26 in this case here, right? So a lot of people saying 25.5. The lower class limit is actually 26, right? What is the upper class limit? Right? What is the upper class limit? What do you all think is that? Right? People saying 35. Yes, the upper class limit is 35. Right? Now, I know what you all are thinking, you know, right? So that's the lower class limit, the upper class limit, right? If I were to ask you what is the lower class boundary, that's something different now. Right? What is the lower class boundary in this case here? Right? So the lower class boundary is actually 25.5, right? And the upper class boundary right is equal to 35.5, right? So make sure you understand the difference between upper class boundary, lower class boundary, lower class limit, and upper class limit, right? Let me ask a question as well, right? This is something that students get wrong in the exam. Could you all tell me what is the class width? It's something students get wrong. What is my class width here for that interval 26 to 35? Right, I'm looking at the answers here. So some of you all have some misconceptions. So class width is calculated by using your upper class boundary minus the lower class boundary, right? So in this case, your class width is going to be 35.5, right, minus 25.5, right? And that's going to give us 10, right? That's a common mistake that students make. What they do, they just take the 35 and subtract the 26, right? So class width is actually given by your upper class boundary minus the lower class boundary, right? So be careful with that, right? So that's a common mistake, right? We see that in exams all the time. Students make that mistake, right? So I just wanted to refresh your memory. Now, why am I doing this? Now, you see when you are drawing your cumulative frequency curve, when you're drawing cumulative frequency curve, you use upper class boundary when you're plotting a cumulative frequency curve, right? When we are drawing something like a frequency polygon, right, we use class midpoint, right? Now midpoint is something that we should be able to calculate as well. Now your class midpoint is simply, now you could either use the 26 and the 35, so you can simply say 26 plus 35 over 2. You can use that to calculate your midpoint. You can even use upper class boundary and lower class boundary. You're going to get the same midpoint, right? So here's what you need to remember. There is something called a frequency polygon. So you could be asked to plot a frequency polygon. in which case you're using midpoint of your class interval and you're plotting that against frequency, right? We can also be asked to plot cumulative frequency curve, and what you are using your upper class boundary and your cumulative frequency in order to plot that, right? Another thing we could be asked is to draw a histogram, which is what I'm going to do now, right? So to draw a histogram, what we normally use, we use the upper class boundary and the lower class boundary when you are drawing a histogram, right? So let's see, we want to draw a histogram to represent this data, right? So I took a little detour here before doing this, right? Let's now. I'm gonna get a graph here. Right, so this is a graph here, right? Now, a lot of the questions that CXE brings for us now, they tend to kind of pre-draw some of the graphs, right? If they don't, then you're gonna have to label it. All right, so this is my data here, right? And I wanna plot a histogram for this, right? Now, again, we are using your upper class boundaries and your lower class boundaries in order to do this, right? So when it comes to the first block that we're gonna draw, right? Your frequency needs to go up to 6, right? So that's the height of the block that we're gonna draw, right? But we're gonna use 5.5 and we're gonna use 15.5, right? That's what you're gonna use in order to create this block, right? So let me see, hold on. So again, it is a histogram, right? Right, now when you draw a histogram, please use a pencil to do this, eh? Right, so the first block, right? The width of the first block, we have to go at 5.5, right? And the width of it has to be going to 15.5, right? So I'm gonna open this here to about 15.5. So that's about here to about here, right? And this first block here is only going up to 6, right? So this is gonna be 2, 4, 6. That's about here. So that's the first block, right? Now the second block, I'll make this a little bigger. It's about here, right? So that's 5.5, 15.5. So the next block now we're going up to 68, right? So we're taking the same width here that we have, right? So, but we're stopping at 25.5, and this time we're going up to 68. So if you're going up to 68, this is 62, 64, 66, this is 68 here, right? That's 68. So that's the second block, right? The next block now, we're going from 25.5 to 35.5, and that is going up to 92, right? So we're taking the same size block again, right? So just remember, a histogram is one in which the bars, they touch each other, which is different from a bar graph, right? In the case of a bar graph, what happens is that the bars are separated, right? The bars are separated, and we use a bar graph for what we call discrete data. Continuous data is what we use a histogram for. Things like time, distance, right? Now this third bar here is going up to 92. So you're going up to, this is about 92 here, right? So that's your third bar, that's 92. The next one is from 35.5 to 45.5, and that's 76, right? So in this case here, right, we have our next bar here, but we're going down to 76. So this is 72, 74, and this is about 76 here, right? And then the last bar now, right, you are going from 45.5 to 55.5. Right, so that's about here, and we're going up to 28, right? So 28 is about here, right? So this here represents my histogram, right? So you could be asked in the exam to draw a histogram. That's typically how we draw the histogram. So you need to understand what your class boundaries are before you can do this, right? So that is part A. You have to draw a histogram, right? This next one here now. We if a group of students, right, surveyed to determine their most challenging subject in class, and the table shows their responses, right? So we have a table here. Right? So a group of students, right, was surveyed to determine the most challenging subject in class, right? So typically students will normally select maths, right? So we have number of students and we have angle, right? So what we want to do, we want to draw, right? We want to, hold on, let's see. All right, so we have a pie chart, right? So we already worked out one of the angles here and we got 144, right? We want to complete this table here. So the first thing you need to do when it comes to a question involving a pie chart, we first need to add up all the frequencies in this case here. So the total number of students is 54 plus 45 plus 27 plus 9, and you're going to get 135, right? So there are 135 students in this survey that it took regarding the subjects that they like, right? Now you want to complete the table here. So let's work out, we need to work out the angles for each of them. So physics, right? All we need to do is to take the number of students who selected physics, which is 45. So this is going to be 45 divided by 135. And you're going to multiply that by 360 degrees. So we're trying to create we want to draw a pie chart here, right? So that's 45 out of 135 multiplied by 360, and you're going to get 120. So this angle here is 120 degrees, right? For chemistry, right, we're going to get 27. So you have 27 students who like chemistry over 135, and you're multiplying that by 360, right? So that's 27 over 135 multiplied by 360, and you're going to get 72 degrees, right? So this here is 72 degrees. And then we need to work out for biology as well, right? So biology in this case is going to be 9 out of 135 multiplied by 360, and you're going to get, right, 24 degrees, right? So this here is 24 degrees, right? So 120, right, 72, right, 24, right? So those are the angles here that we have regarding this thing here. Now the thing is, we want to complete a pie chart, right? You want to complete a pie chart. So in this case, let's switch to, one sec, right? Right? So here's what I'm going to do, right? What I'm going to do here, I'm going to draw the pie chart, right? So we have mathematics already, right? And the mathematics here is this 144, right? 144 degrees, right? And we need to draw all the other sectors, right? Now guys, you need to work with a protractor for the exam. You need a protractor and you also need a ruler, right? So in this case, I'll start with the physics. So the physics is 120. So you're going to take your protractor, right? And you're going to line up your protractor with, let's say, this line here, right? And you're going to measure 120 degrees. So what you'll do, you'll take your pencil and you start measuring coming this way, right? That's now. Yeah, we're going this way here. So this here is going to be 120. So you're going to put a mark here at this point here, right? When you do put that mark there, the next step is move your protractor, and you're going to take your ruler now, and you're going to draw a line. Right? You're going to draw a line coming this way, right? Right? So we drew that line there, right? Remove the ruler. And then we're going to label this as 120. So this is 120 degrees, right? So you must label the angle, and then you're going to write that corresponded to physics. So that's PHYSICS, right? So that's physics here. Next thing now, we still have to do the chemistry and the biology. So in this case here, we're going to use the protractor again, right? And this time we need to measure 72 degrees. So put back your protractor here, right? Adjust it so that it lines up with that last line that you just drew, right? And you're going to measure 72 degrees. So in this case here, you're measuring coming this way. So 72 is somewhere here, right? Around there is 72. So remove this, right? I don't think we need a protractor again. And we're going to take the ruler, right? Place the ruler at the center of the circle here. You're going to draw this here, right? And we're going to draw this line here, right? So remove this, right? And we're just going to write in these angles here. So this one here is 72 degrees, right? And this corresponds to chemistry. All right, let's put chem. And then this angle here is 24 degrees. What you're left with is 24. And this here is your bio, right? So this is typically how we draw a pie chart. We have to calculate the angles of the sectors before we can do anything, right? Right? Yeah, I have like a million messages, so there's no way I could even respond to any message in the chat, right? All right, so that is a question involving it's a question involving pie chart and histogram, right? Those are things that could appear in your exam, right? All right, I'm gonna do a measurement question, right, for you guys. All right, so the diagram shows a cylindrical container used to serve coffee in a hotel, right? So sometimes you go to a hotel, they have this big cylinder that is filled with coffee, right? So you have a diagram here and we have some dimensions, right? And we want to calculate the volume of the cylinder, right? So the volume of a cylinder is given by pi r squared h, right? So pi in this case, I'm taking pi as 3.14 multiplied by the radius. Now the radius is given by this number here, which is 16. So that's 16 squared multiplied by the height, which is 48, right? So this here is going to give me the volume of this cylindrical container that is used to serve coffee. So this is 3.14 multiplied by 16 squared multiplied by 48. Sorry, I'll do this over again. 3.14 by 16 squared multiplied by 48. And you're going to get 38,584, right? Because we have the numbers is so large, right? I'm not going to include the decimal places. So this is going to be 38,584, and this is volume, so that's going to be cm cubed, right? So that's the volume of this container here, right? The next part of the question, hold on. All right, next part of the question here. 20 liters of coffee is poured into the container. Work out the height of the empty space in the container. Now, these are the kinds of questions that come in the exam, and it requires some level of thinking, right? So the container as it stands, right, as it stands is empty. And what you're doing, you're pouring coffee into the container, right? In this case here, we are being told that you are pouring 20 liters of coffee into the container, right? Work out the height of the empty space, right? You want to work out the height of the empty space. Now, the capacity of the container is 38,584. So the volume of the whole container, right, is 38,584 cm cube, right? Now we are being told that you're placing 20 liters, so you're pouring coffee into the container, right? So this volume here, this volume that we have here is 20 liters, right? That's 20 liters, right? Now there's a relationship between liters and cm cube. If you want to convert from liters to cm cube, right? 1 liter, right, is equal to 1,000 cm cube, right? That's something you all need to know. 1 liter is 1,000 cm cube. So if you have 20 liters, that's going to be 20,000 cm cube, right? So that is how much coffee that we are pouring in this container, right? Now the capacity of the container is this amount. So when you put 20,000, obviously you haven't filled the container. So the volume, right, of that empty space on top there, right, that volume of that empty space is going to be 38,584, right, minus 20,000, right, in which case you're going to get 18,584 cm cube, right? This volume that I have here, that's the volume of the empty space above. That's what it is, right? Now, these are the kinds of questions that come. They want you to think, right? It's called critical thinking, right? So that's the volume of the empty space. Now, they want you to work out the height of that empty space, right? Now, that empty space there is a cylinder, right? So the volume of that empty space is actually given by 4 pi r squared h, right? But the volume we know of that empty space is 18,584, right? So all I'm going to do, so pi is 3.14 multiplied by, it's the same radius we're working with, right? From before, which was 16, right? The radius of the container was 16. So this is 16 squared multiplied by h, and that is equal to 18,584, right? So therefore, if I want to work out what h is, it's going to be 18,584, right? All over 3.14 multiplied by 16 squared, right? So therefore, h, as the height of the remaining, that empty space. So we're going to take, let's do this here, 38,584, right? Divided by, open brackets, 3.14 multiplied by 16 squared, close brackets, right? And I'm going to get about 23.1 cm, right? So that is the height of the empty space in this container when I pour the coffee, right? That's the empty space there. Right? Now, I know people ask strange questions sometimes, right? There are some students who ask the strangest of things, like if the January 2025 paper is coming back in June. Obviously it's not, right? I get that question all the time. You're going to get a different paper. It's not going to be the same paper that came in January 2025, right? These questions that I'm giving you here, those are not the questions that are going to come in the exam tomorrow. These are my questions that I normally prepare, right, with my Form 5 students in order to get them ready for the exam, right? So this next part of the question here, right? Let's go. All right, so we have a container that is filled with coffee, right? That big cylinder is filled with coffee, right? And cups in the shape of a hemisphere, right? So a hemisphere is basically half of a sphere, right? Is filled with coffee from the container. The radius of a cup is 3.8. Calculate the maximum number of these cups that can be completely filled from the 20 liters of coffee in the container, right? So you want to figure out, so remember you poured 20 liters of coffee into this container here, And when you are serving the coffee, you're putting them in these small, it looks like a bowl, right? And the radius of this is 3.8. Now this formula for the volume of a sphere is one that students generally don't remember. So CXC typically gives us this formula, right? So what we're going to do, we want to work out, first of all, what is the volume of this hemisphere, right? So the volume, right, of this hemisphere right, is equal to that formula that we have here, 4/3 pi r cube, right? But you have to divide that by 2, right? Because you want half of a sphere, right? Because I have limited space, I'm going to write it across here. So that's going to be 4/3 multiplied by 3.14, that's pi, right? Multiplied by the radius cube. The radius in this case is 3.8 cm, right? All over 2. So that's going to give us the volume of one of the cups, right? That's what it's going to do. So that's 4/3 multiplied by 3.14 multiplied by 3.8 cube. Divide that by 2, right? So one cup, right? One cup actually holds about 114.9 cm cube, right? So that's the volume of one of these things. So one of this here, that's how much coffee is going to hold, right? So you want to figure out how many cups of coffee you can get. So the number of cups of coffee, right, is going to be, we're going to take the 20 liters, which is actually 20,000, right? That's 20,000 cm cube. And you're going to divide that by the volume of one cup of coffee, which is 114.9, right? So we're going to take 20,000 divided by 114.9, right? And you're going to get about 174 cups, right, of coffee, right? So that's how much cups of coffee we're going to get from that, that cylinder that we had initially, right? Yeah, we can't go more than 174. I know one or two people saying 175. You can't go more than that, right? Because we're looking at the number of cups that you could fill, right? 174 you will fill. You might have a little excess, but that's about it, right? Right, when I look at our next question here. So this could come as a question 8 type question, right? So we have an expression here, right? A quadratic expression. F of x is given by 3 minus 4x minus 2x squared. And you want to write that in this form here, right? Now that format there is what we call completing the square. CXC is not going to use the words like completing the square. They will typically tell us to write it in a particular format, right? So there are different ways of working this out, right? I'm just going to use the way that I normally work it out with my class, right? But there are multiple ways of working this out, right? You stick to the method you are familiar with, right? So I have f of x, right, is equal to 3 minus 4x minus 2x squared, right? And you want to write that in this format. F of x is equal to k minus a, open brackets, x plus h squared, right? Whenever you see something like that, we're talking about completing the square, right? So this is what I typically show my class to do, right? So we have 3 minus 4x minus 2x squared, right? So the first step that I do, I write it so that it looks like a proper quadratic. So I'm going to write it as minus 2x squared minus 4x plus 3, right? That's step 1. I'm writing it like a normal quadratic. The second thing that I'm going to do here, I'm going to factor out that minus 2 that is in front of the x squared. So you're going to have minus 2 on the outside, right? And this is where some students not sure what to do here. But we have minus 2x squared minus 4x plus 3. Basically, I'm dividing everything by 2. So if I divide this by 2, I divide this by 2, divide this by 2, what you're going to end up with is minus x squared minus 2x, right? And this here is going to be 3 over 2, right? But hold on, we divided by minus 2. So let's just make a slight change here. Hold on. I'm factoring out minus 2 here, right? So I have to divide everything by minus 2. So this becomes x squared, right? This will become plus 2x, and this will become minus 3 over 2, right? Now, this here is one of those difficult ones that they could bring to kind of mess us up, right? So this here in the brackets will be x squared plus 2x, right, minus 3 over 2, right? Now, if you want to make sure that you've done the correct thing at this stage, what you can look at, you can look to see, if I take minus 2 by x squared, will I get your minus 2x squared from on top? Yes, I will. If I take this minus 2 and I multiply by 2x, will I get minus 4x? Yes, I will. And if I take minus 2 and I multiply by this, I'll get plus 3. So I will. So I know what I have in the bracket there is correct, right? So that's the first step. We factor out the minus 2. Now leave the minus 2 outside here. And now we're going to attempt to complete the square. When you're completing the square, we always have a bracket that needs to be squared. The first thing in the bracket is always x, right? And all we're going to do, we're going to find half of that 2 there, which is 1, right? You're going to write back the term from above, which is the minus 3 over 2. This sign is always going to be a minus sign, and it's going to be this number squared. So 1 squared is 1, right? Now, like I said, different students, they work it out in different ways. Whatever method you are comfortable with, you just stick to that method, right? You just go ahead and you stick to that method, right? I'm not forcing you to use any particular method. This is what I teach my Form 5 class, right? So this is minus 2, and this is going to be x plus 1, right, squared. Now, minus 3 over 2 minus 1 is actually minus 5 over 2, right? And then the final step now is to multiply by minus 2. So we have to take this minus 2 and multiply by this, and we have to take this minus 2 and multiply by that. So when I work that out, right, we're going to get minus 2, open brackets, x plus 1 squared, right, plus 5, right? So therefore, this function f of x that they're talking about here, right, let me write it in the form that they want, right? So the form that they want is going to be f of x is equal to k in this case is 5, right, minus 2 by x plus 1 squared, right? So this is the format that we're looking for here. Right? Yeah, so I've seen some of you all learn off some formulas, right? I kind of glimpse in the chat here, right? So great. If you know the formula, go ahead, right? I've never learned the formula, so I really don't know, right? Formula looks a little too complicated for me to remember, right? So I just know the technique as to how we're gonna work it out, right? This is completing the square. All right, now, like I said, this could come as question 8, right? So the first part, CXC typically gives us like 3 marks to work this out, right? 3 marks to work that out, right? Now, once you've completed the square, there are certain things they can ask us, right? So let me write down the completed square here. So this is f of x is equal to 5 minus 2 squared, right? And the questions being asked now, there are some advantages to when you complete the square for a quadratic, right? So the first part is asking us, part 1, what is the maximum value of f of x, Do you all know what that is? What is the maximum value of f of x? Based on my completed square, what is the maximum value of f of x? Right? Yeah, a lot of people saying that the answer is 5. Yeah, the maximum value in this case here is going to be 5. Right? So you see this constant here, when you complete the square, that's your maximum value of this function. Right? What about part 2? The value of x for which f of x is a maximum. What are you talking about here? What's that answer? Right? Somebody saying the answer is 21. No, the answer is not 21. Right? At what is the value of x for which f of x is a maximum? Right? Okay, so a lot of you all getting it correct, right? Whenever they ask you something like that, what you need to do, you need to put a bracket here equal to 0. So x plus 1 is equal to 0. So therefore, x is equal to -1. So -1, x is equal to -1. That is where the maximum value occurs, right? So the value of x for which f of x is a maximum is going to be -1. The next part here, we want to find the values of x for which f of x is equal to 0, right? Find the values of x for which f of x is equal to 0. Now, when it comes to completing the square, we can actually use the completed square in order to solve our quadratic, right? So you want to work out f of x is equal to 0, right? Our f of x is given by 5 minus 2 by x plus 1 squared, right? And that is equal to 0. You're putting that equal to 0, right? And this is the equation that you're trying to solve, right? So what we can do, we can say minus 2 by x plus 1 squared is equal to -5, right? Then we can also say that x plus 1 squared is equal to -5 over -2, right? So therefore x plus 1 squared is equal to 5 over 2. Then we're going to say x plus 1 is equal to plus or minus the square root of 5 over 2. And therefore x is equal to plus or minus the square root of 5 over 2 minus 1, right? So you can use the completed square in order to solve a quadratic, right? There are 4 ways of solving a quadratic, right? 4 ways. This is just one of the ways, right? So we can say either, right, x is equal to positive root 5 over 2 minus 1, and we work that out. So that's going to be second function square root of 5. Right? And I'm getting 0.58. So that's one solution, right? Or, right, we can say that x is equal to negative root 5 over 2 minus 1. So this here is going to be right, and we're going to get minus 2.58. Right? So this is another way of solving a quadratic by using a completed square, right? Let me just check something here. Okay, yeah. So these answers correct, right? These answers correct. right? So this is one of the ways of solving a quadratic. We can use a completed square in order to do that, right? I want to show you guys something here, right? I want to show you all something here. Now the original quadratic that we have, right? The original quadratic is given by minus 2x squared, right? Minus 4x, right? Plus 3. That's the original quadratic, right? Now remember, all quadratics are of the form ax squared plus bx plus c, right? Now I'm going to show you something here on my calculator, right? So some of you all might look at this and you may be like, I've never seen this before, right? Let's know. How am I going to do this? Right? I'm hoping you all seen my calculator here, right? Now this calculator here, right, is very handy at solving various things. Doesn't have to be a fancy calculator, but it can work out a ton of stuff for us, right? So you can use your calculator if you have one like this or the Casio in order to solve a quadratic, right? So if I press mode on my calculator here and I scroll down to equation and I press 2 and I scroll again, I can go to quadratic and I'm going to press 2. So what the calculator is asking me for, it is asking me for what is the coefficient of x squared, which in this case is minus 2. So you're going to press minus 2, right? Enter. B in this case is minus 4. You're going to press minus 4, enter. C is 3. So you're going to press 3. And what this calculator is going to do is actually going to work out the question for us. I want to show you something. When I press equal here, you realize it's getting minus 2.58. That's exactly what I just got there by manual calculation. Minus 2.58. If I press equal again, you're going to get 0.58, which is exactly what I just got with the manual calculation, right? So this calculator, like I said, it could be used to double check your answers in the exam, right? So let's take that off there. So this is going to be on the recording, so you can check it out after if you want, right? But this is called completing the square, and we can use completing the square to solve a quadratic, right? Now the third part here, right? We are being asked to sketch this graph. Now this is another common thing that we could be asked. If you have completed the square, right, you can actually sketch the quadratic graph, right? So the completed square is 5 minus, so this is what you have. You have f of x is equal to 5 minus 2 x plus 1 squared, right? And you wanna sketch this quadratic here. Now the thing is, we already know that the maximum value is 5 and that occurs at minus 1. So the maximum point for this curve here is minus 1 and 5, right? We know that much. So if I were you and I have to sketch this, right? You know that this graph has a maximum point. So let's put this as x here. Let's put this as y. Whenever CSEC says to sketch, you don't need actual values, right? So let's see. The maximum point occurs at minus 1, 5. That should be somewhere here, right? So this point here is minus 1, 5, right? Based on the coordinate, we know exactly where that's supposed to be. Now let's figure out where is that graph cutting the x-axis. If you want to figure out, where it's cutting the y-axis, all you need to do is to find f of 0, plug 0 into that equation. So that's 5 minus 2 by x plus, 0 plus 1, right, squared. So that's going to be 5 minus 1 squared is 1, so this is going to be 3, right? So what that tells me is that my y-intercept is actually 0, 3, right? So this is something you could be asked in the exam, you know. So let's draw this curve here. So we know that it's a maximum quadratic, so it's going to look like this, right? And then it's going to do this, right? Now this point here, right, that point there is actually 0, 3. That's where you're cutting the y-axis. We also know where these points are as well, right? Based on the solutions that we just got, we got 0.58, We got x is 0.58, and we also got x is equal to negative 2.58. Right? Those points actually tell me where we cut our x-axis. So this point here on this side is actually minus 2.58 and 0. That's the coordinates of this point. This point on this side here is actually 0.58 and 0, right? So we can actually sketch a quadratic based on our completed square, right? We can. All right. I want to do a pattern question with you quickly. All right, so the diagram below, so question 7 in your exam is going to be based on a pattern, right? So we have, the diagram shows a sequence of patterns made using equilateral triangles. Each side, right? Each side triangles are of unit length, right? So if we want to draw, right? We want to draw our fourth pattern here, right? If you notice what's happening here, all you're really doing is adding one more row to the previous triangle, right? So let's say we started, let's start from maybe here, right? So I'm going to draw what the fourth pattern is here, right? So we start off with, let's make sure I'm drawing this correct here. Right? Essentially, we need to start off with the third figure, right? And then work from there, right? So this is our second figure. So this here will be this. Right? So this figure that I have here is the actual third figure. So if you want to get the fourth figure, we just draw in one more row at the bottom here. Right? Now, usually in the exam, this is a little 2 marks, right? So that's an easy 2 marks if you want to figure out what the fourth sequence or the fourth pattern is, right? So that's my fourth pattern. Let's see what the table looks like, right? Alright, so the table shows the number of equilateral triangles and the perimeter of the large triangle. Study the pattern, right, of numbers in each row in the table and complete the table, right? So if you look at the table itself, right, you will notice that the number of equilateral triangles in figure 1, right, you have one triangle, right? In figure 2, you have 2 triangles. Could you all tell me how many triangles do we have in the fourth figure? Right? How many triangles do we have in the fourth figure? How many triangles do we have in the fourth figure? Right? Right? People saying 16, right? Yeah, I agree. It looks like it's going to be 16, right? Now, let's look at the perimeter now. What do you think the perimeter of the large triangle is going to be? Right? We were saying 12, right? I agree it's 12, right? Now, what I normally tell students to do, right? Whenever you work out, let's say the first one or the fourth figure, right? Jump to figure n, right? Jump to figure n. And we need to figure out what is the formula that relates n to, let's say, in this case, the number of equilateral triangles. If you look at the numbers here, 1 is a square number, this is a square number, this is a square number. And if you notice, all you're doing, you're actually just squaring the number or the figure number to get the number of equilateral triangles, right? So if we had figure 4, the number of equilateral triangles is 16, we're just squaring it, right? Now, could you all write down in the chat for me, what do you think this pattern is here for the perimeter of the large triangle? What do you think that formula is? Right, let's see what's happening here in the chat, right? So when we look at this here, right, when you jump from the first figure to the second figure, what you've done, you've added 3. When you jump from here to here, you've also added 3. And when you jump from here to here, you've also added 3. Whenever you have a constant increase, we expect that in the formula, you should have that constant increase somewhere in the formula, right? So in this case here, you will notice that we have 3n. So let's look at figure 1. If I plug 1 into my formula, right, I need to get 3. So therefore 3n seems to work. If I plug 2 into the formula, I need to get 6. Does that work? Yes. So this here is a simple formula. If the answer was not equal to the 3n, right, you will either add or subtract to make sure that you get the correct answer here, right? But if there's a constant increase, then that number needs to appear in your formula, right? So that's the formula there. So now, if you want to complete this table here, right, and you know the number of equilateral triangles is 49, what figure does that correspond to? What figure does that correspond to? Alright, people saying 7, yeah, because the formula is n squared. So if n squared is 49, the figure has to be that, right? What about the the perimeter of the large triangle? What's the perimeter of the large triangle here? All right, I've seen some answers coming in here, right? So guys, just remember to do me a favor, make sure and hit like, and please remember to click subscribe, right? If you have not done so as yet, right, you're getting a free session here. All I'm asking you to do is to hit like and hit subscribe on my maths channel here, right? Just do me that favor. That's all I'm asking you for, right? All right, so you want to figure out what figure number corresponds to 69. All you need to do is to put 3n is equal to 69, and therefore n is equal to 69 divided by 3. So therefore n is equal to 20, how much? 23, right? Or is it, right? It's 69, right? Right? How come you're all getting 21? Where 21 come from? right? All right, so this one here is going to be 23. So that's figure 23, right? And if you want to figure out the number of equilateral triangles, it'll be 23 squared. So in this case, you're going to get 529, right? That's how many triangles, equilateral triangles you're going to have here, right? So this question wasn't too bad at all, right? Right, I just want to do one transformation question here for you guys, right? Actually, let me start off with, do this one. Now, your third question in the exam can have geometry inside this, right? All right, let's have a look at this here. So we have a quadrilateral, right? And we have some angles inside it, right? And we have some lengths that are equal. So for example, this length here is equal to this length. So that makes that triangle an isosceles triangle. If this length here is equal to this length, that also makes this triangle across here an isosceles triangle as well, right? Now, we want to calculate angle BCD, right? Angle BCD. So let's have a look at this quite carefully, right? Right? Now, BCD is actually this angle here. That's what you want to calculate, right? So whenever you have a question like this here, so this angle here is 38 degrees. So because it's an isosceles triangle, I can work out these two angles here, right? This angle here is actually 180 minus 38, right, divided by 2, right? 180 minus 38 divided by 2, that's going to give us that angle there. So that's 180 minus 38 divided by 2, and you're going to get 71. So therefore, this angle here is 71, and this angle here is also 71. It's an isosceles triangle, right? So this here is 71 degrees, right? What that allows me to do, I can actually work out, you can actually work out this angle here, right? That green angle, this here, is actually 180, right, minus 71 plus 28, right? And this is going to be 180 minus, open brackets, 71 plus 28, close brackets, and you're going to get 81. So therefore, that angle here, this green angle, is going to be 81 degrees, right? So if you want to work out, right, if you want to get this angle here, right, that angle and this angle here are going to be the same. So this is going to be 180 minus 81, and you're going to divide that by 2. So that's going to be 49.5, right? So that angle that they want here is 49.5 degrees, okay? So this next question here, a regular polygon, right? So all right, a regular polygon has n sides, right? A regular polygon has n sides. Each exterior angle, right? Each exterior angle, right, Yeah, a regular polygon has n sides, right? Each exterior angle is 5n over 2. Calculate the value of n, right? Now, when it comes to a polygon, right, there's a formula, right? There's a formula to work out the sum of the interior angles, right? So when it comes to interior angles, you all need to know this formula. So the formula is given by n minus 2 multiplied by 180 degrees, right? That's the sum of the interior angles, right? When it comes to exterior angles in a regular polygon, right? Exterior angles, right? Exterior angles actually add up to 360 degrees, right? Now let's read this question here. A regular polygon has n sides. Each exterior angle is 5n over 2. Calculate the value of n, right? Now when students see questions like this, they're not sure what to do, right? So in a question like this, right? So the sum of the exterior angles of a regular polygon adds up to 360, right? All the exterior angles add up to 360. Now if I take 360, right, and I divide this by n, that's the number of sides of the polygon or the number of angles in the polygon, right, I'm actually going to get 5n over 2, right? Now sometimes when students see questions like this, they don't know how to interpret this. So you have a polygon, right? We don't know what it is, right? A polygon is basically a plane shape, right, that has equal sides. That's all it is, right? What they're telling us here is that each exterior angle is this here, right? So if I take, remember the sum of the exterior angles add up to 360. If I take 360 and I divide it by the number of angles we have in the polygon, I'm getting this answer here, right? So you're coming up with an equation and you're going to figure out how many sides this polygon has, right? So in this case here, we can cross multiply. So we can get 5n squared, right, is equal to 2 by 360, right? So therefore, n squared is equal to 2 by 360 over 5. So therefore, n squared is equal to 2 by 360, right, divided by 5, and you're going to get 144, right, 144. So therefore, n is equal to the square root of 144. So therefore, n is equal to 12. So we are talking about a polygon that has 12 sides, right? And if it has 12 sides, each angle is actually going to be 5, right, multiplied by n, which is 12 over 2. So therefore, each angle or each exterior angle is 30 degrees, right? Now, this is one of those things that students may just get wrong completely, right? Right, now remember, any third question we can get transformations, right? So we have 3 triangles here, right? And we want, let's see. Right, I don't know if you all see in this here, right? So the first part, right? So we have 3 triangles here. Describe fully the single transformation that maps P onto Q. So here's P, right? And here's Q. Do you all know what kind of transformation is that? What kind of transformation is that? Right? I hear some people saying translation. Yeah. So what's happening here, you will notice if you look at P and Q, you will notice that there's no change in size. There's no change in orientation, right? So if you were to describe this, it is going to be a translation, right? And you need to specify the vector. if you don't specify the vector, you're not going to get the marks or the full marks, right? All you need to do is to start with one point here and see what vector takes me from that point to that point. If I go 1, 2, 3 units to the right, so the first number has to be a 3, right? And then you're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So therefore, it's a translation with vector 3, 9. So whenever you are asked to describe a translation, please make sure and put what the vector is. If you don't put the vector, you're going to lose a mark, right? What about the second one here? Describe the single transformation that maps P onto R, right? What maps P onto R? Look at where P is and look at where R is. What translation maps P onto R? Right? Some people saying rotation. Right, guys, when you all are describing a rotation, right? When you're describing a rotation, there are certain things you need to see, right? So the first thing, just by looking at it, you will see that this P and this R, right? The shapes are identical. They are considered congruent, right? They have similar dimensions, but you will notice that the orientation has changed. If the orientation has changed, it means that there has been a rotation, right? Now we're trying to figure out if it's a rotation. So let's try the center, right? Let's draw a line from here to here, right? Right, to this point on the triangle here, right? And let's draw based on what we see in here. This side is 2 units. This side up here is 2 units. So let's join, right? If you're looking for corresponding points here, let's draw a line from here to here, right? So what is actually happening is this whole triangle, right, is rotating, right? It is rotating through an angle of 90 degrees, right? So here's what you need to say to get the marks here. So 1, you're going to say it's a rotation, yes. If you all want to get full marks to this, you need to specify whether it's clockwise or anti-clockwise, right? Now you can describe this as clockwise or anti-clockwise, it doesn't really matter. In this case here, we go in clockwise, right? It's going in the same direction as a clock normally moves. So it's clockwise. You must specify the angle. The angle is 90 degrees based on what we see in here. And also, right, we need to specify the center of rotation. You need to say all of this in order to get your marks. So center of rotation, right? In this case here, the center of rotation is this point here, which is 0, 0, right? So this here is 0, 0. That's the center of rotation. So when they say describe the single transformation, there's a lot of information that you have to include in order to get the mark, right? Right, so let's see. All right, next thing we want to do now, right? We have our next part to this question. All right, so we have one more part to this question here, right? Right. So on the grid here, right? On the grid, we want to perform, right? We want to enlarge triangle P. The scale factor is 3, and the center of enlargement is 4 minus 6, right? How do we do a problem like that? So first things first, right? You are interfering with triangle P, right? And the center, right? The center of enlargement is 4 minus 6. So 4 minus 6, right, is going to be down here. So you need to locate that point first, right? That's your center of enlargement, right? 4 minus 6. If you want to enlarge this thing here, what you're going to do, you're going to draw some projection lines, right? So let's draw the projection lines first, right? So that's one line. You're taking a ruler to do this, by the way. Then we're going to draw a next line here, right? And then we're going to draw a line from here going up this way, right? So those are your projection lines. Now the thing is, the scale factor is given by 3. So K is equal to 3. How am I going to use that, right? Now the best way to do this is by using, you can actually use a compass, right? Or your divider. You know that tool in your geometry set that you've never used? The one that has the 2 pointy ends, right? So here's how you're doing that, right? Now you can use this if you want. Let's start with this point here, right? What I'm going to do, I'm going to open this to the size of the distance between the center of enlargement and one of the vertex of this thing here, right? Then we're going to come here and you're going to check. This is already one length here, and the scale factor is 3, so you're going to go 1, right? That's 2, right? That's 2 lengths here, right? And then we're going to come here and that's going to give us 3, right? So this point here, sorry, right? That point there is where we're going to get our, so let's say around here, right? Somewhere about here, right? So that is one point when I'm projecting it where it's going to be, right? So this distance here, right? Plus this distance here, that's 3. That's your scale factor here we're talking about. You're going to do the same thing for your other points on your triangle. So place the pointy point at the center of the enlargement, right? And what I'm going to do, I'm going to open this to the width, right, of where that vertex is for this triangle here, right? And we're going to do a measurement now. So that's 1, right? That's going to be 2, right? And this here is going to be around 3, right? So that's going to correspond to around here, right? So this is where the other point of this triangle is going to be, right? We're going to do it again now, right? But we're going to do it now, put the pointy part here, right? Well, I can't do it with this here, so I could do a measurement, right? So from here to here, from the center of enlargement to this point, that's 2, right? But the scale factor is 3 here, so this is 2 and this is 3. So the base of this triangle is going to be here. So in order to construct this triangle here, all I need to do is draw a line from here to here, right? Draw a line from here to here, right? And then draw a line from here to here, right? And that is your enlarged triangle, right? With scale factor of 3. And this point here is your center of enlargement, right? Which is 4 minus 6, right? So that is how you perform an enlargement, right? All right. All right, guys. So this is as much time as I have, right? That's as much time as I have, right? So I hope that you all saw something you may not have seen before, right? So I just want to wish everybody good luck in the exam tomorrow, right? Read your questions carefully. Read your questions carefully, right? Time is going to be your biggest enemy in that exam, right? Time is going to be the biggest enemy in the exam, right? So I know some of y'all watching this and thinking you've never seen this before, right? So typically, what I normally do, I take 1 year and 8 months to get my students ready for the exam, right? I don't take 1 year alone. I take 1 year and 8 months. Students start by me typically in Form 4 in order to get ready for that exam, right? So it's not you can't rush maths. It takes a while to really understand maths, right? So I know you all want me to stay longer, right? But this is as much time as I have. So I just want to wish everybody good luck in the exam tomorrow, right? Take your time, answer the easiest questions first, right? And try your best, right? If you are unsuccessful for whatever reason, right? Just remember January 2026 is right there, right? But just go into the exam and try your best, right? The result that you get is the amount of work that you put into the maths exam, right? So guys, that's it for me. Enjoy the rest of your afternoon. Be safe, right? And good luck tomorrow, right? Take care, guys.